Hi there. In SAT math, you must be prepared to think out of the box. Let's start at the beginning, a review of negative numbers. I'd like you to pause the video now and do the problems you see on the board. Okay, let's go through the answers. The best way to quickly do this is actually to physically do a number line here, and then both denominators being equal, you can tell on a number line that negative 3 is less than negative 2. So the answer here is less than. Again, the best thing to do is to draw a number line. And you know that negative 25 is here somewhere and negative 10 is here somewhere, and it's very easy to see that negative 10 is greater than negative 25. What if you have two different denominators? Bring them to the same denominator. So you want to rewrite this problem as negative 4/7 could be turned into, let me write it down here, you want to compare negative 4/7 and negative 2/5. If you multiplied this by 5/5 and you multiplied this fraction by 7/7, you will get negative 20 and negative 14. Now you can draw a number line, and you know that negative 20 would be here somewhere and negative 14 would be here somewhere. With the denominators being equal, you can simply compare the numerators, and negative 20 is less than negative 14, so there should be a less than sign here. Let's go ahead and look at 3/5 and negative 2/5. This is relatively easy. Both are in the fifths. If this is 0, 3/5 would be on this side of 0, and negative 2/5 is here somewhere, and you know that 3/5 is greater than negative 2/5. So when does the expression negative x represent a positive number? When you multiply or divide the negative with another negative. So whenever x is negative, so when x itself is a negative number, because negative times a negative number gives you a positive number. An equality must be flipped whenever you multiply or divide both sides by a negative number. So whether you multiply or divide by negative number. When is x minus y negative? Whenever y is greater than x, regardless of the sign. What is a simple way to tell quickly whether a product, quotient, or power is negative? And when the number of negatives in the term is odd, then the result is negative. So let's just say number of negatives are odd, the result would be negative. When the number of negatives are even, the result would be positive. For example, you can say negative 3 times negative 3 times negative 3 will give you a negative answer because there's odd number of 3's here. Or you can say negative 3 times negative 3 times negative 3 times negative 3, and there are even number of negative 3's, and this will give you a positive answer. If x minus y times y minus x is negative 10, then x minus y squared is equal to what? Think before doing any algebra. So let's go ahead and think. X minus y and y minus x, these are the same set of numbers, but they are reversed, and the answer is negative 10. You're either multiplying negative by positive or positive by negative. So x minus y could either be a negative answer or a positive answer. We're asked to figure out what is the square of that. And the square of that could be the same answer, same numerical answer, but a positive 10 here. Because if I decided x minus y was negative, then y minus x would be positive, or if I decided that x minus y was positive, y minus x would be negative. And we are asked to take one of those and square it. So you can see that you can do this problem without even doing any algebra by simply looking at the numerical value of this, the absolute number value of this, and then thinking about positives and negatives. So the actual numerical values, whatever it is, it's going to be the same. Simplify the following expression without the calculator. So here we go. We can keep the top as 9x minus 18. And if we can reverse this bottom number and pull out a negative, you get 9x minus 18 as well. You can check your work by distributing. Negative times 9x gives you negative 9x. Negative times 18 gives you positive 18. And all I did was just reverse this so that it looks exactly like the top. And I can cancel this out. And my answer is simply negative 1. Let's do this one without a calculator. You must know negative 5 cubed is negative 125. Negative 1 to the power an even number will be a positive answer. It's a positive 1. Divide by 2 to the power even number is going to be 16. 5 to the power odd number, and we should know that this is 125. You don't have to multiply 16 by 125. You don't need to pick up your calculator. If you leave it separate, just like I've shown you, you can see that they cancel out, and the answer is negative 1 over 16. Look at this problem here. This is an SAT problem. Let's read this. A sequence of numbers begins with the numbers negative 1, 1, 1, and each term afterward is the product of the preceding 3 terms. How many of the first 57 terms of this sequence are negative? So let's go ahead and see how the sequence turns out. The best way to do this kind of problem is to actually write it out until we can see a pattern. So this is the product of the preceding terms, which is negative 1 times 1 times 1 is negative 1. So the next one is going to be negative 1. And it says 3 terms. So the 3 terms will begin here. 1 times 1 times negative 1 is negative 1. Next, preceding 3 terms, negative 1 times negative 1. It's an even number of negative numbers. So you know it's a positive. Times 1 is positive. Let's see if we can do a couple more and then look for patterns. 3 terms, so it starts out here. 2 negatives gives you a positive, times positive gives you a positive again. So this is a positive 1. So they're all 1, and the pattern goes negative, positive, positive, negative, negative, positive, positive. And we probably should do one more just to check to see if our pattern is correct. The preceding one, as predicted, after 2 positives, we should get 2 negatives again, which we will in this case. Negative times positive gives you negative. And if you look at the preceding one here, 2 positives gives you positive, times a negative gives you a negative. So I think this is about enough. We get a pattern going here. And the pattern is negative, positive, positive, negative. Negative, positive, positive, negative, and I'm expecting it to repeat. The question is, how many of the first 57 terms of this sequence are negative? Well, we know that there are 2 negatives in a group of 4. So let's figure out how many groups of 4 are found in 57, and if we double that, we'll figure out how many negatives, right? So 57, how many times 4 will go into 57? 1 4s are 4, 4 4s are 16, and there's a remainder 1. I'm just going to put a 1 remainder here. So there should be 28 negatives. If you multiplied this by 2, there should be 28 negatives. But then there is a remainder, and we need to ask ourselves, what would the remainder be after the very last group of 4? The remainder is a negative, and we are asked about negative, so we have to add one extra negative, and our answer is 29. Let's try another. This is an inequality problem. If negative 2x is less than negative 7 and y is less than 2.5, which of the following must be true? So let's go back to the question and spend a little bit of time understanding what's given and what can we do with it. My first instinct tells me that if I have negative 2x less than negative 7, then I want to divide both sides by negative 2. And x, don't forget to flip the sign, is positive 3.5. And y is given as less than 2.5. Let's go ahead and draw a number line and understand where x and y falls. So if this is 0 and if this is 2.5, and it's an open circle because it doesn't say y is less than equal to, so the y values are in this direction all the way to infinity, and here's 3.5, open circle, and x is greater than 3.5. Now let's look at the choices. The first choice says that x and y must be a positive number. You know that as soon as y gets to be negative, this is no longer true. So we want to eliminate the first one. That can't happen. Now let's check the second one. Can x minus y possibly be greater than 0? And remember that it says must be true. So we have to pick a few numbers. Let's say we picked something 3.6. And 3.6 minus a number here, this is a larger number minus a smaller number, will always give me positive. And as the y numbers get smaller and smaller, we will always get a positive answer because 3.5 is going to get larger and larger. For this to be true, the y must always be smaller than x. This is the condition. Y must be less than x. And this is true. So we're going to keep this one. This is a yes. Now let's test this one. Is x greater than 3? Of course it is. We just figured that one out. So that's a yes. So our correct answer is C. So this is an interesting question here. Let's look at this. The sum of the integers from 15 to 50 inclusive is equal to the sum of the integers from n to 50 inclusive, where n is less than 15. And we're supposed to figure out what n is. N is the number of integers that you're going to add from less than 15, and when you add them up, your answer should be the same as that. We are asked to find another number n, and if we add n to 50, it should give us the same answer as 15 to 50. So the only integer we can come up with is negative 14. If we add negative 14 to 0, and then 0 to positive 14, the entire sum will end up being 0, and we're back to 15 to 50. And this is what we wanted our answer to be. You can pause the video and think about it for a little bit, and I think it'll come clear if you have some time to think about it. Read this question. If 0 is less than A, less than B, less than C, less than D, less than E, which is less than F. So you want to stop reading right there and try and figure out what it really means. It's best to draw out what's written. It makes it a lot easier. So your 0 is here, and it looks like this is your A, B, C, D, E, and F. So A minus B would be a negative answer. C minus D is a negative answer. E minus F is a negative answer. There's odd number of negatives, so the x is going to be negative x is equal to b minus a is the same as a minus b, but it'll be positive. D minus c is same as c minus d, but it will be a positive. F minus e is same as e minus f, but it'll be positive. So it'll be some positive number here. And let's just put a question mark here because we really don't know what these numbers are. So let's solve for x. If you solve for x, you will divide by that same negative, and whatever these numbers are, they will simply cancel out. And it's irrelevant that you don't know the actual numbers. And x would be simply negative 1. And the answer is D. This is the last one in my series of negative numbers. B, negative B, negative B, negative B gives you negative 4b. So this whole thing here turns into negative 4b, and your final answer would be positive 4b. And the answer is B. Okay, thanks for listening. Goodbye. I'll see you again.